Okay, welcome to this video. So today we're going to explore a question that I adopted from AMC past contest. So the question says, in triangle ABAC and the angle BAC equals to 40 degrees, AB equals to 10 and AC equals to 6. And we will have a point D and E that are respectively lying on AB and AC. So that's everything given to us. But now we're trying to find the minimum value of the sum of this expression, which is like BE, the distance from B to E, the distance from D to E, DE, and CD, the distance from C to D. I really encourage you to pause the video, sketch the diagram, and try the question yourself. It's a very interesting question that I really encourage you to give it a try. If you fail, continue the video, and I'll be waiting for you. Okay, I hope you've tried the question. So in the meantime, I have sketched the diagram that we actually need. So this is the triangle, and for convenience, I have labeled the length of AB here 10 and AC 6, and this is the angle. The reason why I didn't really put D and E here is because that there are a pair of naughty boys that are still running around. I mean, we can't really know where they are at this exact moment, but we will figure it out soon because we're finding the minimum value. Yeah, how do we find the minimum value of two random points connecting to each other? I mean, could you visualize that? DE, connect, right? 3 lines. They're kind of random. Yeah. So, the first step we're trying to do is to know a property. Let's imagine there are 2 points. I'll call this A, I'll call this B, and yeah, here's a river, and from point A, there's a happy man. He's so happy that he wants to get some water to water the plant on point B. I'll name this plant. So this happy man wants to fetch some water from the river. Let me draw it. Okay, let's assume the point is, the line is river. So this happy man wants to go to river and get some water for the plant. But he wants to find the shortest distance because he's kind of exhausted. I don't know why he's still happy, but let's hope that he'll find the shortest distance. But how do we do that mathematically? It's really hard to just find a point that really can't just this is a point C, that AC plus BC, then I have it bigger. AC plus BC is the smallest value, but there's one thing that we can do. Let me erase this C. Let me do a reflection of point B, and with this as a symmetrical line, and I can have point B here, and call this B prime. And now I connect these 2 points. Because the shortest distance between 2 points is actually a straight line. What does this mean? It actually means that from A to B prime is the shortest distance from A equals to from A to B, because this is B prime is actually the reflection of B. So if we actually connect, label this as C point and connect BC, because it's actually a reflection, so BC equals to CB prime, and AC is still the same. So we actually managed to find the shortest distance from A to B by doing the reflection of B prime. And the happy man can fetch the water from the river in the shortest distance with his exhausted energy from nowhere, maybe coming back from school or something. but we helped him and we are happy. Okay, now back to this question. Put this in your mind though, it's very important. Back to this question. So what is this question asking for? Point D and point D are a pair of naughty boys. I mean, they're just kind of hard to deal with, but there is something that we can do. We can try to find the reflection of point B as like using AC as the symmetrical line and do the same operation for point C as well. So find the B prime and the C prime. That's okay, because let me first draw it first. Okay, I have just sketched the diagram. So I have reflected C to C prime and B to B prime through like by AC the symmetrical line and AB the symmetrical line for each. Now, because we are trying to find the minimum value of BE plus DE plus CD. We already know that DE, like D lies on AB, right? E lies on AC. So actually, DE is like already known, is between this part, and CD is somewhere that we are, CD and B is somewhere we're still trying to find. But here comes the magic. Imagine if I connect C prime and B prime. We actually manages to find the shortest distance from C prime to B prime, and that actually cross AB and AC, and that is where we can find B and A, like D and E, because that is the minimum value we're trying to find, and we can actually fold it back, and that makes sense. Let me first draw the line. Okay, I have connected C prime and B prime. So, according to the question, this should be point D now, and this should be point E. And we can also try to like manage like fold it backward, like if I connect C and D, C prime D will equals to CD, as well as B prime E will equals to BE. So this should be the shape that should come out for the question. Like BE is this part, DE is this part, and CD is this part, and we managed to find the shortest distance. So now the challenging part is actually to find the length of B prime to C prime. How do we do that? We actually know that AC equals to 6 and AB equals to 10, right? AB equals 10 and AB equals to AB prime, right? So let me label that this equals 10. AC equals to AC prime, right? So this equals 6. And now, because we're actually folding the whole triangle, so we also managed to get this equals to 40 and this equals to 40. What does this remind you of? You know this, the angle, and this. Yeah, try to think. Yeah, it's the cosine law. If you're not familiar with cosine law, let me just briefly explain you the formula. So cosine law is when a triangle, I'll just assume this as PQR. So the length of PQ, or let me just assume X, Y, Z for the distance. So the square of Z equals to the square of X plus the square of Y minus 2 times XY times the cosine of angle PQR. That is cosine law, and we're going to apply this here because we know this for AC prime, QR for AB prime, and the angle. So we're going to apply this here. This shall be B prime C prime equals to square of AC prime square plus AB prime square minus 2AC prime times AB prime times cosine of C prime A at angle C prime A B prime. Let me simplify it a bit by substituting numbers in. Oh, my bad. This should be a square. Let's substitute the numbers in. This should be the unknown number. Let me just like change it to something else easier to write. Okay, this is a sum, right? Just let me use S because it's a sum. And AC prime squared is 36. Like 6 squared, you know? 6 squared is 36. AB prime is a 10. 10 is 100. 2, this is still 2. AC prime 6. AB prime 10. And this is cosine of angle 40 plus 40 plus 40. I don't need this angle anymore because I have the value already. That is 120. So S squared equals to 136, like plusing this 2, minus this is 120. 2 times 6 times 10 is 120 of cosine 120. So cosine 120 it is an obtuse angle. I mean, if you are a beginner of trigonometry, this may be unfamiliar to you, but for obtuse angle, we need to actually create a coordinate system where this is 120 degrees, and you basically apply the same law. So this is a right triangle that you should build, and just do cosine for this angle theta, which in this case should be 60. So you just do cosine of 60 instead, but you should note that this is actually negative. So cosine of 60 actually equals to 1 over 2. But in this case, this part should be negative. So you should actually, so cosine of 120 equals to negative 1 over 2, just in case you don't know. Like, just get more familiar to these concepts. So this is 136 minus 120. Let me erase this. Times, we know that already, negative 1 over 2. So we have two negatives, that is a positive. This equals to 136 plus 60. And to our surprise, this is 169. What is special about 169? But let me just move this here. It is special because 169 is surprisingly the square of 14. So we can directly have S equals to 14. In this case, S cannot be negative because it's a sum of 3 lengths. We're doing geometry question, so we don't want to consider negative. Yeah, so the final answer is S equals to 14. 14 is the answer. I hope you get it, and if you enjoy the content, definitely try to do everything YouTube has. I'm okay with it, so okay, have a great day.